We live in a simulation. Sounds crazy, but it isn't. The simulation hypothesis can be as real as the tips of your fingers. What I mean by a simulation is simply just a programmed reality, much like a modern realistic video game. But how can we prove this, and is there any evidence for it? Believe it or not, some things can be explained through the simulation hypothesis. First, let's learn about how our own computer simulations work. When you are in a game, the only thing you can see is what's in front of you. Everything behind you doesn't exist anymore. The computer has to create it, which happens when you turn around. And after that, everything behind you again doesn't exist. The programmers of the game have to do this in order to reduce the load on the computer's processors. Keep in mind, everything you see up close, the computer has to render in extreme detail, and faraway objects not so much, like real life. But what connection does this have with the real world? Well, quantum mechanics can point to our universe being a simulation. The double-slit experiment. Remember this experiment that baffled all scientists? You pass light through a surface with two slits in it, and a sheet in front of the two slits. You expect to see two bands projected on the sheet, but no, you see multiple. The reason? Light behaves as a wave, not a particle. But we soon found out that electrons and other subatomic particles behave the same way when shot through the two slits. We see the interference pattern. Using detectors to see what's happening, the particles seem to behave as we expected them to in the first place, and two bands are seen. It's as if the mere fact that just observing something can change the way it behaves. How would this link to simulations? Well, it's possible that our reality is programmed so that things only exist if they are observed, like this double-slit experiment. It's just too hard on the computer if it had to render and load all of this even while nobody is looking. The simulation hypothesis can also explain quantum entanglement. Certain subatomic particles can have a certain angular momentum we call a spin. If an atom emits two photons, one photon will always have the opposite spin of the other when observed. Even if we don't observe the other photon, the mere fact that we observe the first one influences the other, and the information about the photons is transferred to the other instantly, even if the photons are at a huge distance from one another. Also, the photon doesn't even know which way to spin before it's observed. This means that the photons must be communicating faster than the speed of light, which shouldn't be possible. However, if we assume we live in a simulation, this can be easily explained. Both of the particles' programs are connected to one another, so if one changes its spin, the other can instantly get its spin too. And so, like all computers, the load on the hardware is greatly reduced as the processor doesn't have to go to each individual photon to make it spin. These are just two examples. There are many more to feed evidence to the simulation hypothesis.